Okay, an electron with kinetic energy of 8 exponent negative 16 joule passes perpendicular through a uniform magnetic field of 0.4 exponent negative 3 Tesla. It is found to follow a circular path. Calculate the radius of the circular path and also the time required for the electron to complete one revolution. Good. So this is about what? This is about you have a charged particle, okay, a charged particle, electron. Okay, electron is a negative charge. Okay, passes perpendicular through a magnetic field. Okay, you have a magnetic field, and then you have a circular path. Okay, so this one is electron circular path in magnetic field. Is more to charge moving in the magnetic field. Charge moving in the magnetic field. So it is okay. So it is this one. Yeah, motion of charged particle in uniform magnetic field. Like this one, electron. Okay, moving in a magnetic field. So it make a circular path. Okay, maybe it's clockwise or maybe it's anti-clockwise, depending on the direction of magnetic field and direction of magnetic force. Okay, FB equal to FC. Right. So the magnetic force is equal to the centripetal force. This one, yeah. So okay, let's draw it out. Let us draw out. Maybe okay. Let's say our magnetic field is going into the page. Yeah, let's say our magnetic field go into the page. Okay, and this is our negative charge. Okay, this is our negative charge. So let's say it's moving in this direction. Okay, our magnetic field. This is our magnetic field. Okay, so okay, if using our right hand rule, okay, all right, we have this negative charge. Okay, right hand rule. Don't forget all the palms, the fingers. Okay, these are my right hand, let's say, and this is my palm. Okay, so the direction of finger is the velocity of the particle, the palm is the magnetic field, and then what about the thumb? But this one is a negative charge. This one is a negative charge, so it opposite the thumb. So it is opposite the thumb. So the magnetic force is opposite the thumb because it is a negative charge. Okay, if it is a positive charge, then only it follow the thumb, the magnetic force. Okay, right now it is a electron, so it is opposite the thumb. Yeah, we use this one. Okay, so after I use this hand, I can find my direction of magnetic force acting on the electron. Okay, let me use it. Yeah, so I won't show here because I already teach you in the previous video. Okay, the direction of how to determine the direction of magnetic force. How to determine the direction of magnetic force for a moving charged particle in a magnetic field. Okay, I already showed you in previous video. So this one I just draw it straight away. Yeah, so I use my right hand. Okay, velocity is the finger, magnetic field, the palm pointing into the page because the palm is the magnetic field. So my thumb actually is pointing upwards. My thumb is pointing upwards, but because it is an electron, so the magnetic force should opposite the thumb. So instead of going upwards, the magnetic force is actually downward. The magnetic force is actually downward. Okay, so this one become the centripetal force, and so the center will be at the below here. So the circle will be the circle will be where? Where is the circle? The circle will be below here. Okay. So it will go clockwise direction. Okay, it will go clockwise direction, and so we have the radius of circle. and then we have the period of revolution, we have the frequency, which is 1 over period, etc, etc. You can find omega some more, yeah, 2 pi f, all sorts of things you can find, yeah. So okay, is that correct? For my diagram, yeah, referring to the notes, if a magnetic field go into the paper, the negative charge, it is clockwise. Is it correct? Yes, like this one, you see, magnetic field go into the page, and electron is clockwise. You see that? It's clockwise. So my assumption is correct. Okay, it's clockwise. Okay, so that's all. Now I want the calculation part. Yeah, I want to find the radius. The radius of the R. So how to find the R? Okay. So and then the following question is the time required for electron to complete 1 revolution. So it's the time for 1 revolution. That's period. That's period. Okay, because period is the time. Period is the time required to complete 1 revolution, to complete 1 cycle. That's period. So okay, so we want to find the radius and period. So we can do it. Okay, so we start from this relationship, FB equal to FC, because it is the magnetic force. Magnetic force provide the centripetal force. Okay, so we start from there. Okay, so question A, I want to find the radius, so I start from magnetic force equal to centripetal force. Okay, and then magnetic force is BQV sine theta. Then centripetal force is mv squared over r. Okay, I can find my radius. You see that? Okay, now theta. What is the angle theta? Theta is the angle between V and B. Okay, because we previously learned about QV cross B. QV cross B. So the angle theta is between these two. The person who cross each other. The persons who are crossing each other, which is the velocity and magnetic field. The theta is the angle between these two. Yeah, the person in crossing each other. Yeah, velocity and magnetic field. So can we find the theta? The theta, he say, electron passes perpendicular through a magnetic field. Okay, so passes carry the meaning of velocity. Yeah, perpendicular to who? Perpendicular to the magnetic field. This is the magnetic field is the B. So from here we can see velocity perpendicular to magnetic field. Can you see that? So velocity perpendicular to magnetic field. So that's the perpendicular is the angle between velocity and magnetic field. So we got the theta. The theta is 90 degree, yeah, 90 degree between these two, velocity and magnetic field. So sine 90, sine 90, okay. So it's BQV sine 90. Okay, and then I can sine 90 equal to 1, velocity and this square don't have anymore. So rearrange the formula, we got this formula, mv over bq. All right, mv, this one go to the top, bq go below, so mv over bq. Okay, so now this velocity, do we have the velocity? No, but we have the kinetic energy. We have the kinetic energy. This kinetic energy is equal to half mv square. So from here we can find the velocity, isn't it? So okay, let's find out what's the velocity using the formula kinetic energy equal to half mv square. And this is an electron. So electron, we are using mass of electron. Okay, we are using mass of electron. Okay, let's find out. Okay, kinetic energy is 8 exponent negative 16 joule equal to half mass of electron. Mass of electron, if not provided in the question, you can find from the list of constant also. Yeah, in the list of constant also provide electron mass. Yeah, mass of electron 9.11 exponent negative 31 kilogram. You can find from the list of constant, the mass of electron, and also the charge of electron also can find. Yeah, so you can all is in the list of constant. Okay, if the question didn't provide, never mind. In the list of constant, you have the mass of electron and the charge of electron. Okay. Now, okay, mass of electron is this one lah. Yeah, just use the value given. Mass of electron 9.11 exponent negative 31 kilogram, and then velocity. Okay, that's a velocity. Okay, let's calculate the velocity because we need it. Okay, 9.11 exponent negative 31. Okay, and then divide by 2. Okay, and 8 exponent negative 16 divide by this answer. Okay, and then I need the square root. Don't forget the square root because it's v square. It's v square. See that? It is v square. So you don't forget you have to square root the answer. So then only you get the answer. Then only get a final answer, final velocity. 4.191. Yeah, 4.191 exponent. 4.191 exponent 367. So it's exponent 7 meter per second. Okay, so I got the velocity already. So I can continue this part. This one also mass of electron. Yeah, use mass of electron. And then this one, the charge. This charge is using charge of electron. Yeah, Q is the charge of electron. Okay, charge of electron. But here it already give you electron per mass, isn't it? So I think you can use this value. All right, never mind. Write back the. Okay, wait. This is correct. I mean the electron per mass. I think you can use this value. Yeah, this mass, the electron charge per mass of electron. Electron charge per mass of electron. Okay, per mass of electron. So you can use the charge just now. The charge just now is charge of electron, isn't it? The charge just now is the charge of electron because you're using electron. So this electron per mass. So I can say this one become what? This one become I can say, okay, put in the value. Yeah, put in the value. I can say that this is electron over mass. Where should I write? Yeah, maybe I write over here. Yeah, never mind, just write it over here first. Electron per mass is 1.676 exponent 11, right? Okay, so if mass over electron, if I invert it, yeah, just now is electron per mass. Now is inverted mass over electron. That means this one also invert. So it become 1 over 1.76 exponent 11. Okay, isn't it? Okay. So alright. So right now this one is velocity over magnetic field, mass over electron. Here also we have mass over electron. So I can substitute this one. I can substitute. I mean this one. I can I can use this one, this value. Okay, velocity over magnetic field times mass over electron. So mass over electron is 1 over 1.76 exponent 11. I put into here. Okay, I think I can substitute all the values. Velocity first. Velocity is this one, this value, 4.191 exponent 7. And then magnetic field. What is the magnetic field? 0.4 negative 3. 0.4 negative 3. Okay, 0.4 negative 3. That's correct. And then mass over electron is 1 over 1.76 exponent 11. Okay. That's correct. Okay. So I should get the answer of radius. Yeah, let's calculate for 4.191 exponent 7 divided by this 0.4 exponent negative 3 multiply by divide by, okay, 1.76 exponent 11. Okay, so the answer is 0.0.5 0.60, yeah, 595 0.595, which is 0. If you round it up, it becomes 0.60 meter. That's the answer. Okay, am I right? Yes, that's correct. That's my answer. 0.6 meter. Okay, that's my radius. 0.6 meter. Okay, so I got the radius. Now I want to find the time required for 1 revolution. That's period. So to find the period, question B. Okay, so can I find the radius? How to do it? Yeah. Okay, we know that V equal to R omega. Okay. This is a circular motion. This is actually the circular motion. You understand? This is actually circular motion. So circular motion has the formula V equal to R omega. Still remember your circular motion formula? V equal to R omega. And we know that omega is 2 pi f. Omega is 2 pi f or 2 pi over period. I can find your period here. Understand? V equal to R omega, can find your period here. So substitute into the formula. We have V equal to R omega is 2 pi over period. Hey, wait, this is R. This is R. Okay, R omega is 2 pi over period. So V is actually 2 pi R over period. Okay, so I can find my period. Okay, so period is actually 2 pi R over velocity. So my radius is 0.60 meter, and my velocity is this 4.191 exponent 7. That's my velocity. So what's my period? So let's find out my period. 2 pi multiply 0.6 divided by this 4.191 exponent 7. Okay, divided by 4.191 exponent 7. So the answer is 8.995 exponent negative 8. Second, that's the answer. Or 9 exponent negative 8 also can, yeah. So okay, is the answer correct? 8.995 exponent negative 8. Second, that's correct. 9 exponent negative 8, yeah. It's close to this one, 8.995. This one is 9 exponent negative 8. Second, okay, that's the answer. Okay, or you can also do you can also do the other way. You can also do from the FB equal to FC. FB equal to FC. This is BQV sine 90 again. This is MR omega square. Yeah, instead of using MV square over R, last time FC is MV square over R. You can also change it to MR omega square, isn't it? MR omega square. So you can find omega from here also. Omega from here. All right. This V changed to R omega. Yeah. This V here you change to V equal to R omega. So you can find your omega here. You get omega, and also can get the period out of it. Understand? Can get omega is 2 pi over period. Can get period from it. So, but this is a simpler way. Yeah. It's just circular motion. Back to your first semester. Yeah, that first semester circular motion. V equal to R omega. Omega is 2 pi f, or 2 pi over period. That's all. Yeah, or you find frequency first. Once you got the frequency is 1 over period. You can get from period. You can get the period from the frequency also. It's the same thing or everything. Yeah. So that's all for these questions. Yeah, very simple questions. Okay, bye.